Number 1 we did in class?
Yes.
Yeah.
Okay, so we'll start with number 2 then.
If you did the data.
Number 1 was the lid, was
1
it?
over 0.
Yeah.
Yes.
And 2
We
how
and we have to make sure it's correct as well. We don't know.
how many?
Twenty-five.
Okay, great. We're rolling. Okay, I don't think I have my calculator. Do I? Where's my calculator? No. Doesn't matter. You can use your calculator. Right, so, can you read the... Well, I'll just write down number 1 so we have it all in one spot. The turn in force. What did I give you in the question?
Force and D, F and D. Gave and we have to
Are you
find
sure?
L.
No,
L and
L.
D we have to find
I
out.
said L is 1 Newton meter and D was 4
Yes.
centimeters. Yeah. So,
centimeters.
no, I got it. So, L equals dF. F equals L over D, which is 1 over 0.04, which is what's 25 newtons. And I think everyone got that
Yes.
last time. So let's have a look at number 2, which is the first diagram.
A braced cantilever steel beam is supported by a 26 centimeter steel.
Okay, pause. I need to draw the information as you read it. So it's cantilever. So it's like this. And the stay you said is
supported
26.
by 26 centimeter steel.
okay, so that's 0.26 meters. And what else?
The stay is 10 centimeters above the hinge,
Yep.
and the beam is of length 24 centimeters.
Okay.
Mass 25 kilograms. What is the tension and the stay?
25 kilograms. So the force here is 25 G. Now, Iyad was making this point the last time, and it's an important point. I never said in the question that the stay goes from here to here. Maybe it was like this. But if you think about it, if this is 24 and this is 10, then from Pythagoras this must be 26. Why did I write some of them in meters and some of them in centimeters? I should keep it the same. (26 centimeters). Okay, it has to be like this. It can't be the other way. Let me give you an example where it's not like this. So, for example, I tell you that this is 3, this is 8, and my stay that I have is 5. Yeah? So is this right if I draw it like this? No, it's totally wrong, because from these, they don't work. Yeah. So I must draw it like this. How much must this piece be? 4. And how did you get that? Pythagoras, yeah. So then that means this piece here is 4 as well, okay? So it's because of Pythagoras I know the picture must be like this. That's okay. Now, what angle did you call this here? This angle, what letter? Yeah. But you don't like my theta, so we'll call it alpha then. So this part here is T. So this one is T cos alpha, and this one here, T sin alpha. And what did I want, Adnan, in the question? Is it the T?
What is the tension and the stay?
Yeah. Okay. Now, we actually can know the alpha though. How can we know the alpha? I can say alpha equals tan inverse
10 over.
10 over 24. So what did you get for
22.6.
22.6. Great. And then I should use turning force where? Where should I put the turning point? Here? Yeah. Here, at the hinge. Yeah. So, this one clockwise or anti?
It's clockwise.
Very good. This one?
And
No, this one? This one don't care.
yeah.
This one? Anti. So, and what's the distance here? 0 point here to here? 12. And the force?
25 G.
And that should equal
T sin
22.
here to here? The distance?
0.24.
0.24. And the force?
T sin.
T sine alpha.
Yeah.
Can you get the T?
Yes.
Easily. What did you get? I don't have a calculator.
you put the unit and now
319.1. So 319 then.
Oh, okay.
that's
Yeah.
Not too bad.
well,
It took you like 20 minutes in class last time to get this. Yeah, because it's difficult at first, but can you see it's not...
I was following you.
I'll just take it.
Yeah. Do you know this expression in English, the blind leading the blind?
What?
Do you know this one? Yeah. Yeah.
From
Yeah.
where do you get point 1, 2,
It's half of 24 because it's in the middle. Yeah. Okay. Can we look at number 3 then? Why, what are you writing down? What did you do wrong?
I did it right. Then we were having a fight,
Yeah.
and then he, tried to explain me, and then I said, okay, that's right, and then I changed the answer. Then I cut the answer, and then I wrote.
So it's your mistake for believing him. Yeah.
Yes, so next time.
Next time, don't believe him. Right, okay. 3 then.
A braced cantilever
Mhm.
supports a 40 centimeters road.
Okay, so it's braced, and it's, what did you say, 40 centimeters?
Supports a 40 centimeters road.
Okay, so this is 40 centimeters, okay.
Of mass 10 kilograms.
Okay, so let me draw that in. This is 10 G, okay.
The strut is 50 centimeters.
It's a strut now, is it?
Yeah.
Okay, so it's a strut, and you said it's
50
Fi-
centimeters long.
right. And anything else we're told?
The struts provide vertical support.
Okay, blah blah blah. Yeah, yeah. Give me the numbers.
How much reaction force is this?
Right. Okay. So what you have here is you have a 50 centimeter strut. Okay. I suppose I really should have said in the question, which I didn't. I don't think I said this is attached to the end, did I?
No.
No, you didn't. Wait.
Yeah. Oh, I did say it?
At the end of the road?
Oh, I did. Okay, fine. Yeah, yeah. So this is 50 centimeters, which means how much is this?
Which is 50 minus 40.
Yeah, yeah. From Pythagoras, it would be 30.
Yes.
30
Why
centimeters.
is 30?
From Pythagoras. From Pythagoras. Okay. So let's put in more forces. Okay. There are 2 more forces I need to draw. What forces am I missing? Yeah, but where?
Between the wall and
The wall and the
Yeah, there's definitely a reaction here.
and the point down.
So I don't know, I'll call that one S or something.
And the other, the what?
Yeah,
The wall.
yeah. Now the question is, which way to draw it? Do you know, like, should I draw it straight up?
Okay.
At an angle? At an angle? What do you think? Well, firstly, did I draw the S right? So let's think about it. What does this want to do? It wants to fall down. So there's definitely something here.
Yeah.
Now, is it being pushed into the wall or pulled out from the wall?
Push.
Yeah, well, it's a bit hard. I think if I have this up against the wall and the strut is here, and if it wants to fall down, it wants to come out from the wall.
Yeah.
So I feel like maybe the wall is pulling in. Yeah, so maybe I should draw it like this. Because if this wants to fall down, it's trying to come out from the wall. It's not being pushed into the wall. This is the difference between the stray and the strut. The stray is pulling it into the wall, but the strut is almost like stopping it from falling out from the wall. So I think I should draw it like this. I think. Unless somebody really disagrees, which is fine, because it's good to think about these things. Does anybody disagree?
We are with you.
Yeah? You disagree?
No, we are with you.
Okay, you agree then, right. So then, this makes it clearer for how I should draw this reaction. How should I draw it here?
It's not as opposite like this.
No problem.
Yeah, I think I should draw it this way. Because remember, the up equals the down and the left equals the right. So if there's a force going left here, then I need a force going right here. And if there's a force going up and up here, I need one going down. So I feel like this is the right way. In fact, I wouldn't be surprised if it actually went exactly like this, but we don't know for, I think we can say it's exactly like this. Like this. Because if I try and draw this, you can use your imagination. This is the connection. Yeah.
Like the door?
No, it's like sitting on it like this. So I feel like it's pushing this way along the strut. Do you see what I mean? I think this is exactly a straight line from the strut. It's pushing with the strut. Do you know what I mean? Yeah? That's what I think. I don't know if that's what you did.
Maybe it's up, because it's only about the surface which is connecting with the strut doesn't have a direction, so I think it's only up.
Yeah, this is where it gets complicated, but you know, it has if it's connected with a nail, it's like with the door hinge. It's really complicated. I know what you're saying. It doesn't have a direction because it's just connected, but it actually does have a direction, because imagine it was with a nail attached, like I hammer a nail into it. What does this want to do? It wants to fall down. Yeah? So this one here, it's true, supporting it upwards, but it must have some horizontal force because it's not moving horizontally. I know it's very difficult, and I'm not even 100% happy with this. So if I'm not 100% happy, you shouldn't be either. But I do think it should be like this. Now you might be saying, why am I not happy if I made this question? I don't know. Maybe I didn't think about it enough. Maybe I made it too difficult. But I think I should draw it like this. Okay, because the way I picture it in my mind, it's kind of like this, the stray, except upside down. So when you drew the stray, you see how you had the tension with the stray? So I just picture it as being upside down. So this is why I feel like I should draw it with the strut. Yeah. I think that makes sense. Yeah. Okay. So where do we want to? Oh, well, let's resolve. Here we'll call this alpha, and here, and we'll call this or. So this is or cos alpha. That's the last question. And this one here is or sine alpha. Yeah. This alpha is the same as which angle here in this triangle? The top one or the bottom? This alpha. Is it the same as this or this?
Yeah.
No, which? It's
No.
only one of them.
If we draw a line like this,
Yeah, here. This alpha is the same as this.
yeah,
If you remember this from middle school, opposite angles are the same. So, what's tan alpha? Or sorry, I should say, what's alpha? Tan inverse. Tan inverse what?
Opposite over 18.
Yeah, so that's what numbers? Come on.
Sine.
Tan inverse.
It's it's 40 upon 50? 30 upon 50. 30 upon 40.
Yes. 30 over 40. Because this is the opposite and this is the adjacent. Yeah. Right, so where do we want to put the turning point? Sorry, I left out my other reaction here. Where do I want to put the turning point? Yeah, for the calculation. Where do I put the turning point?
Near the S.
Yes, I must put it at the S because I don't know anything about the S and I don't want to know anything about the S. So I put the turning point here. Okay, this one, clockwise or anti-clockwise?
Clockwise.
Clockwise, this one?
And
No, don't care, and this one? Anti. So again, just like with the last question, what's this distance? What's this distance?
20.
20 times 10g should equal 40 times or sine alpha. Now somebody, can you give me the alpha please?
Yes, it's 38.65.
Thank you. Okay, so now give me the or please. Thank you.
I got 38.65.
You write this down?
It's 36 point.
Oh dude, you're the one with the calculator. What is it? 36.9. And the or? The or will be, if you type this in, 81.7 newtons. Thank you. Yep. One more question, is it?
Yes.
Great. Wait a second, I just want to make sure everyone has this. In the exam, the question is a little bit harder than this, not much. The only difference in the exam is what they like to do is put in a weight or something at the end of the beam, so there's an extra force, you know, like 20G or something. So in other words, they basically just add in one extra turning force into the formula. I mean, it's not a big deal, okay? Like if I said, oh, here there's a weight, is it clockwise or anti-clockwise?
Clockwise.
Clockwise, so you just add it into this part, yeah. So I mean, that's not a big deal, right? So just for my homework, I just kept it a bit simpler, but in the exam, it's just a tiny bit extra work to do. But it's really not much extra. Yes? What's different? In the exam? A little different. Like in the exam, they usually put a weight here, like maybe like 5G. So then here you would have, I don't know, whatever, 0.3 times 5G plus. That's all. That's no big deal. Okay, can we go on to number 4 now? Right.
A braced cantilever iron beam is supported by a 30 centimeter stay.
Okay, so we have a braced cantilever iron beam, and it's a 30 centimeter stay. What else do we know?
The stay is 5 centimeters above the hinge.
Okay, so here, look, this here to here is 5 centimeters.
And the beam is of length 15 centimeters.
Okay, now look up here, please. The beam is 15 centimeters. This is 5 centimeters, and you said the stay, sorry, what was it, 3 centimeters?
13.
Sorry, what did you, 13?
A braced cantilever iron beam is supported by 13 centimeters.
1-3.
Okay, 1-3. So, look, everybody look please. Is this right or is this wrong if I draw this?
We can use the...
But firstly, is this right or wrong? No, this is totally wrong. Because the longest side should be this. But it's not. This is the longest side. So this is totally wrong. I can't draw it this way.
So it's not connected.
It's not fully to the end. It's more like maybe to like here or something. And this is 13. Now using Pythagoras, how big is the base from here to here? If this is a 5 and this is a 13, from Pythagoras, what's this distance? This is 5, that's 13, and this is
13.9.
no. You did. I know exactly what you typed in.
Square
No, you typed in square root 5 squared plus 13 squared, didn't you?
But it will be minus that.
12. You forgot the it's minus.
It will be
It's minus?
minus.
What?
Yeah, because you're looking for this side. You have x squared plus 5 squared equals 13 squared.
13 squared.
Yeah.
It's 12.
Yes, it is. Right, so then how much is this extra...
1.
Try again.
3.
Thank you. 3.
Oh.
Yes, yes. The total's 15. Yeah. Okay. Now, what did you say the mass was, Adnan?
20 kilograms.
20 kilograms. Okay. So right in the middle here, there's a 20g. And this distance, what's the distance from here to here?
7.5.
Very good, 7.5 centimeters is this distance. Yeah, and then the distance from here to here we said was 12 centimeters.
Yes.
Yeah, and then this is our t. Now I don't know if I zoom about here. So this one is t cos. But do we really care about this one?
No.
No, because it's going to go through the turning point. So we really just care about this one, don't we? Which is t cos or sine? Sine. And can someone give me the angle? It's tan inverse 5 over 15. Tan inverse 5 over 15 is 18.4 degrees.
5 over 15.
Yeah. 18.4 is it? Can you double check?
Yes,
Okay.
18.43. Yeah.
4.3, okay. Like this. Right, so once again, we'll take this as the turning point. And what's the first force? Clockwise or anti-clockwise?
Clockwise.
Clockwise in this one? Anti. So we have 0.075 multiply 20g. What should that equal?
It's 14.715.
0. No. The,
14.715.
I'm making the equation. Yeah.
0.05.
0. No. 0.12. Clockwise equals anti-clockwise. That's what I'm doing. And then the force?
T sine.
T sine 18.43. Okay, sorry. Now, Mir, you were giving me the number on the left here, was it? Yeah. But you know what? It doesn't matter because I'll just take both of these over here and do it in one step on the calculator. So that's 0.12 sine 18.43. So I get T equals.
$490.5.
Agree?
Can you go?
Yeah, zoom out.
It says what is the magnitude and direction.
Oh yeah, so we have a little bit more to do. Oh well, no, actually, no, we have the magnitude, that's the T, and the only thing is it this? Is it 491? No? What did you get?
But in there you have to.
Has 2? What do you mean?
So it has to.
Oh yeah, I just put this underneath for T. So like, let me show you. We'll close this door.
Why is it so different? If I divide it by 14.
Okay, wait. Go back to this step, okay?
Yeah.
So here, are we happy with this?
Yeah.
Happy?
Yeah.
Yes or no? Happy. Right, so all I did, I just took this underneath.
Yeah.
Divide,
And sign of.
you know?
I got
And then, yeah, also divide by sign. Sign. So I get T equals 0.075, 20, 9.81 over 0.12 sine 18.43, and we get
387.87.
387.
Yeah.
Point.
387.9.
So 388.
Okay.
Okay.
Something.
Yes?
When I divide it by 14 point, when I divide 14.715 with 0.038, it gives me 387. And when I divide it by 0.03, it gives, like, now it's giving 490.5.
When you divide by 0.
038
Why 0.038?
up to 3 decimal places. If you lose.
Huh? So the first time you divide by
0.038. The second time 0.03. No 8.
oh, that's why. That's too
Yeah.
big of a difference. Yeah. Yeah, you need to have a few more digits. 3 significant figures at least.
2.038, so 38, there are still 2.
I know 2's not enough. Like for calculations, you really, in the exam they recommend having 4 significant figures in the exam. So like for example, 0.003812692, you should use at least 0.0038113. You should have 4 significant figures at least for calculations in the exam. And your answer should be to 3 significant figures. Okay. Right, 388 then.
389. Okay.
Yeah, no, if you got 389, that's okay. 388 I think is the closest. Okay. We can close this.
Can I see the...
Yeah. Yeah. Now the question asks for the magnitude and direction. So, Adnan, this is the magnitude, and the direction is just the angle here. The alpha is 18.43. Wait, hang on. Did it ask for the reaction or the tension?
Of the reaction.
Ah, we're not finished. We're not
Yeah,
finished.
we have
Yeah.
to continue it.
Yeah, we're not finished this yet because the question then wanted
R.
here the or. Yeah. So that's not too bad. If I just draw it again, let me zoom in. Sorry, I thought I was finished. If we look at the or, it has a horizontal and a vertical. So what I'll do is, can I redraw this maybe just like here at the side? So we have an or x, and here we have or y. Then what else do we have? Going down we have a weight, don't we?
Yeah.
What's that?
20G.
20g. And then what do we have here? This is t cos, and this one is t sine. Now what's the t?
389.
389. Cos. 388 is what I had, wasn't it? And what's the cos? The angle.
18.4.
Okay. And then here, this is t sine.
Yeah.
Like this. Now, this isn't so difficult because how can I... What's the or x? Everybody look up. What's the or x? It's 388 cos 18.4 because they have to be equal. Yeah? So we have or x. What's that, please? Can you tell me? 388 cos?
368.16.
368 newtons.
Yeah.
Now, how can I get the or y? How can I get this one?
It's
Does it also include,
ry plus t sine is equal to
That's it, that's
20
it.
degree.
You can say ry plus
Alright.
388 sine 18.4. That should equal
20
20g. The up should equal the down. So then, can you tell me what the ry will equal? Are you writing this, Mahmood? Yes, okay.
Can I use the clockwise should equal the
Good question. Can you do that here? You know, you can actually. And you should get the same answer. So if you wanted to do it that way, you could. Yeah, the clockwise equals the anti-clockwise, yeah. The only thing I would say is,
3.79.
don't put the turning point here, because then both of these cancel. You should put the turning point like here.
20g minus.
Yeah.
Right?
Yeah, it's 20g minus. So
Yeah,
it's 73.729.
70,
3.729.
yeah, 7. Just also to say, Musharif had a good question here. Could you use turning forces? And you could, you'll get the same answer. The only thing I'm saying is, if you do use turning force here, don't put the turning point here, put it here, because you don't want to cancel these. You do actually want to find them. Anyways, let's scroll down. So this is 368, and this is 73.7. So to finish, I need the magnitude and the direction. So I need to calculate this. And I need to calculate this. Do you have the first one? 375
375.
newtons at an angle of, and what's the angle here? It's going to be pretty small, like 10 degrees or something, isn't it? 11 degrees, I was close. 11.3.
3.
Okay, 4. 4?
No, it's 3.
Oh.
It's 265.
11.32.
3.5 we'll say, in the middle of it.
No, but 3.2. Let's do it.
Okay. Okay, so we'll move on to the next lesson now. This last question is a little bit more like what you get in the exam, because it has more steps to it.
Excuse me,
Yeah.
I don't understand much about this question.
This part,
No, last part.
yeah, this part here, is it this part?
No, in the last.
Oh, in the last part, here.
Yeah. Y and 5.
Yeah.
Y is alpha.
Why is it what?
Alpha.
Alpha.
Why is it alpha? Alpha. Here's alpha, yeah?
Yeah, so Y is 18.43.
Oh, why? Well, I hope they did it right over there.
I think it's 22.6.
What is?
what?
Huh?
Sorry, again?
Give me. Hang on.
What is?
Tan. No. We'll see. I know what happened. This is my fault. I'm so sorry. You are right, and this is my fault. I'm so sorry. I told you earlier to do tan inverse 5 over 15, and that was my mistake. It wasn't this. Thank you for spotting that. I should have been tan inverse 5 over...
7.0?
No?
3.12.
Yes, thank you. It should have been that.
Why 12?
Because the triangle is 512. And I looked at it as 515. So yes. Now that's not a big problem. It just means that all the angles change. Okay? And I'm not going to do it. I'm sorry. The answer's wrong. And the reason it's wrong is because the angle is wrong. Okay? It should have been
Now there is no place on my page to correct it. I was
Just write a note on the top that says 18 should be 22.6. Yeah. Yes. Thank you. See, the problem is when I have ICT, it takes too much energy from me. There's too many of you. Yeah. You want me to go to the last page here, is it? Yeah.
Five of one.
So beta will,
So this is wrong.
yeah, so it will be 45.
What would be 45? You got the right answer?
I think.
Let me see.
No, up.
Up. You're saying for this answer here, is it?
Yeah.
You got 45. And then, is this different? Does this change as well? Yeah, it would change because this plus this and this is wrong. Yeah. You got 138.7. You can check if she's right later, okay?
In the can.
And then you can post a comment. You can post a comment on the YouTube video then. Okay. Yep. All right. Can I close this now? Yep. Okay.